In the previous class, we were talking about environments. We focused on environments, the different aspects that we can find in an environment. But today, we want to look at the agent or the types of agents that we can have. We looked at an agent function, right? We said an agent function tells the actuators what to do. Now we have something else on top of a function. We've got an agent program. So an agent program implements an agent function. Right. So we're going to look at the different agent programs that we can have, which we simply term the agents. So we have simple reflex agents, right, that responds directly to the precepts. We've got model-based reflex agents, right, that track aspects of the world around. So there's a model in place. Then we've got a goal-based agents, right? So all they're doing is to find a way of achieving their goal. And all of these agents can improve their performance through learning. So let's look at these agent programs. So this box here looks at this agent contains also a program and also a function. So let's look at a simple reflex agent. Right. So once the sensors take in input, this is what is called the program. This is the program that is running from the moment. This is the agent program. A reflex-based agent would then say, what is the world like right now? So it gets that information from the sensors and interpret information from the sensors. And then based on this, we are going to choose an action to do based on these two inputs. Right? If the information, if A, do that, if B, do that. So this is the function. This is the function. It tells the actuators what to do. So that's the difference between a function and a program. So that's a simple reflex agent. So it invokes a knee-jerk. Let us think of the Mars rover, for example. We haven't been able to fully model Mars, right? So we are sending robots there to investigate for us what Mars is like, to collect samples, to try and see what we can get from there, right? So that's the nature of the environment. So now we put in the Mars rover there. It is going to go and react to situations that we are not yet familiar with. Right? So we cannot fully model Mars, right? We don't have enough information to model Mars. Therefore, any agent we put there is going to be reactive. Right? So we're going to talk about learning in a bit, but it can learn from these reactions so that it will map. Right? So that's one way an agent can work. So reflex agents work well in scenarios which cannot be modeled. A mine is collapsed. Right? A mine is collapsed. Right. Someone needs to put in a robot there that can navigate to find survivors. So it will be fitted with whatever sensors and so forth, but it has to find its way through because number one, maybe there is no time to model it, or there's not enough equipment to model it. What the collapse structure looks like underneath. So we may need to use a reflex agent. Is it a good thing? If we do not know about the information there, so the model or the agent can do something to further collapse the mine. So it's take or give to identify where it can be used. We have a model-based reflex agent. So here we have most, if not all, of the information about the environment that we are in, right? So, or at least we know that the environment should not change whilst we are still modeling. In a model, you have got the different states. So you can say, if you have done 2601, then you should be familiar with the finite automata. You're saying, okay, we are starting here, right? Right. We're going to take this path. If we get if the agent encounters an object, it is going to use decision A. If it doesn't encounter an object, it is going to. So this becomes different options. So we have already mapped, right? We have an idea of how we're going to respond to situations. Yeah. If you have got a mapping robot, something you want an agent to map an environment for you, right? And you have got no information about it, you are not able to predict the states of that environment, right? So that is what a model is. You have information about the environment, and you can model, you can have a visual model of the environment, and you can try and replicate it. So you take your input. This again is your agent program, and then your function is then what tells the actuators what to do. Right. So you've got your state, how the world evolves around, and what my actions do. So you've got a state, right? You've got options, and what the actions do, takes you there or takes you there. Right. And then you have got the conditions. So because you now have additional information, this makes a big difference. Well, let's think of a practical example that we can use for a model different from a reflex-based agent. Say you are driving. The robot in front of you is red, right? And so you see it's red, and you are, say, like 500 meters away, right? You know that as you get closer to the robot, right, you are now starting to expect it to be green. So instead of coming to a full halt, we might just reduce speed, right? Because red tells you to arrive and stop. But you're saying you can adjust accordingly, reduce speed, because in the model, if it is red and it has been red for 10 seconds, it's about to get to green, so prepare to leave. Right? Or just adjust your speed, by the time you get there, to be green. So you have got a knowledge of how the robot or the traffic light model works. Then we have got a model-based agent, but that is goal-oriented. These are still model-based agents, like we discussed, but they are driven by a goal. In that model, right, we know what the world is like. What will it look like if I do an action? The question becomes, would I have reached one of the goals? If the answer is no, right, it is still going to look at the action that brings it closer to a goal. So that's a goal-based. Then we have got a utility-based agent, right? So it is still a goal-based agent, only that the goal is happiness or utility. How happy will I be in such a state? So here the goal is happiness or the performance measure. Right? So in other cases, the goal might not be a performance measure. It might be something specific that you're trying to target. So that is a goal-based agent. And lastly, we have got a machine learning agent. So irregardless of what it is, any machine can learn. Right? So you've got information, right? Two information inputs, the environment, and a performance standard. Right? We know that this is how it performs. So the information from the sensors goes to the critic and compares from the information from the performance standard. We want to see, right? So control systems were the first to utilize this. So if you wanted to keep something in equilibrium, the sensors tell you that it's not in equilibrium. The performance standard will tell you to get to equilibrium, do this, right? And then it will give feedback, and then the learning element will know next time if something like this happens, you do that, then it effects changes, right? And gives a performance element, in which then goes to the actuators. Right? So from the sensors, we also have flow of information to the learning element. From the sensors, you go to the performance element. It performs an action and it sends knowledge to the learning element. So what does that mean? I do something, then I know whether or not I record that I had this scenario and this is the action that I did. Right? And then the actuators perform the action. Right? I can then gauge and say, okay, well, was I successful or was I not? Right? So that is now knowledge that goes to the learning element. Additionally, good learning agents produce problems for themselves. Right. The Google AI that was supposed to keep secrets from the third one, we see, or for it to get the encryption right, or to get to a language right, they had to produce problems for themselves, right? In the absence of an environment, we can take the third one as an environment, but in the absence of an environment, they had to generate a language which could not be deciphered by anyone. So they had to produce tests for themselves to take. So we have a visual problem generator internally as well. If I do this, what will happen? If I do this, what will happen? Right. All right, so that is a learning element. So the learning element can be applied to any of the modules that we've discussed. All right, so that's it about the agent. In the next video, we're going to be looking at problems and how we can define a problem in the AI space.